this isn't just about drones.
This is about a passion that I made into my job. Hello, I'm Jason Bloomer, and I'm studying film production at the SAE Institute in Zurich. For my advanced specialized project, I built an FPV drone, and today I'm going to show you how to build your own. First of all, what is FPV? FPV is an abbreviation for first-person view. Now, using FPV remote-controlled vehicles started in the early 2000s, when enthusiasts started to put small cameras with an analog transmitter on RC planes and use small monitors to see where the drone was at. Today we have a much stronger digital signal, which is transmitted to goggles so you can see your camera feed. So, what is the difference between an FPV drone and a normal commercial drone? Well, most FPV drones are completely manual. This means you have complete control, but close to no assistance. Most of the FPV drones are also very fast, but have a very short battery life. In this video I will talk to you how to assemble the drone, give you a quick overview about the setup, I will give you my conclusion and my learnings, and I will talk about some sources that helped me with the build. Now in the end I will show you my first test flight and some clips that I've taken since I've built the drone. For this build you will need a few tools. Most importantly, a screwdriver, you will need a soldering iron and solder, and if you have available a heat gun, or you can also use a lighter. Now, for my drone I chose to build a 5-inch quadcopter. This means that the propellers are about 5 inches. This is the perfect size if you want to carry something like a GoPro. As you can see, I bought my frame on the fpvframe.ch website. I chose to build the Floix V3. For the setup, I chose purple TPU, a dual SMA antenna plus GPS, and the O4 Pro as a video transmission system. I work at the store, so I picked out the parts myself and started 3D printing. Then I laid them out for a quick preview of the parts. Alright, now that everything is laid out on the table, I'm going to quickly explain what we have, and this is every part apart from one we need for the drone. So, we have the carbon parts, these make up the base frame. We have the video transmission system, that's the O4 Pro from DJI. We have the X Nova motors, these are 2207, 1850 kV motors. We have the flight controller and the ESC from TBS. We have the main power cable, different source of cables. We have the 3D printed parts to assemble. We have the battery strap, we have the battery pad. We have different types of screws, but this is every screw we need for the drone build. First of all, we have to assemble the basic frame. For this we'll need the top plate and the middle plate and the 4 arms. There are designated screws that we'll use for this part. After making sure the 3 layers are firmly together, we can go onto the motors. This drone is made to be a push configuration. This means that the motors look at the floor and pushes the drone upwards instead of pulling it. To attach the motors we use 4 screws with a little bit of Loctite at the end to make sure the screws won't come out with the vibration of the motors. Next, I learned that the best way to attach the motor cables is to use tape and stick them neatly to the arm. The next step is to start with the electronic components. As you can see, I am pre-soldering the electronic speed controller, or ESC for short. This is what controls the motors of the drone. I am using the TBS Lucid Pro ESC. The soldering iron is at about 450 degrees, so I can heat up the pad and let the solder flow onto it. After soldering all the pads on the ESC and letting it cool down, I can use the conformal coating on the bottom to protect it from the dirt. After we attach the motor cables, we will coat the top part as well. Conformal coating is UV reactive, so it glows underneath a black light. Here you can see me checking if I missed some spots. You can do the same. We coat every electrical part after it is finished. This is how we protect the internals of the drone. After the coating has dried, we can attach the ESC to the frame with 4 screws. The screws are long enough so we can build the stack from there. Be careful which direction you will put the ESC because the main power cable runs from the ESC. Then we'll continue to cutting the motor wires to the right length. Don't cut them too tight, you want to leave them some room. As you can see, I always cut a wire and solder it onto the ESC. For me, this was the best way to measure how long the other cables had to be. Now there is no right or wrong way of attaching the motor cable, I just went from right to left and repeated the same steps for all the other motors. We are not quite done yet with the ESC. We still have 2 pads to connect, the big plus and the big minus. Now on here we will attach the main power cable and the capacitor. Now the power cable is thicker, so you will need more solder. Be careful that you correctly use the plus and minus polarity. For the capacitor I used 2 cables that I cut to a certain length and connected them to the capacitor and to the same soldering pads as the main power cable. I dipped the open end of the capacitor into Plastidip so it's protected against water and dirt. The capacitor is a safety feature in the circuit to protect the other electronics from voltage spikes. Be careful that you do this correctly, we will see later why this is important. Now coat the ESC on top and continue. The ESC is now finished, so we continue with the flight controller, FC for short. The flight controller is the brain of the drone, and this is what we later set up. Now on the flight controller we will attach certain electronics. We will connect the GPS, the receiver via soldering, and the O4 Pro and the ESC via plugs. First of all, I will be pre-soldering all the pads that we need to use. Then I will check the wiring diagrams of the FC, the GPS and the receiver. I'm going to wire the GPS first. The GM10 Mini V3 has 6 wires we have to connect. A ground, a 5V, an RX and TX, and an SC and SD. These have specific places on the flight controller. Now with the help of the wiring diagrams from the producer, it is pretty easy to connect them. When soldering these small pads, be careful that when you strip the wire of isolation, try and keep the open end as short as possible. Now the receiver. Same as the GPS, this has a designated place on the flight controller. However, only 4 cables. A ground, 5V, RX and TX. Same as with the GPS, we can look at the wiring diagram directly from Team Black Sheep to look where we have to connect it. We can connect the T antenna to the receiver and shrink wrap the whole receiver so the antenna is locked in place. I've been talking a lot about the RX and TX, but what does it exactly mean? It's pretty simple. The TX stands for transmission and the RX is the receiving end. So if you connect the cables, you basically have a circuit of the data transmission. You have one sending out the data and one receiving the data. This is how the components talk to each other. As you might have recognized, I already attached the O4 main body to the frame. You can do this now too. Use 4 screws and the 3D printed part and attach it to the back of the drone. Remove the stock antennas and attach the SMA connectors, which we screw into the GPS mount. Be careful which side is up on the drone, because I got confused and attached it the wrong way around. When the FC is dry, you can put it onto the stack. Be careful where you put the cables. This is slightly different depending on what drone you have and how long the cables are. I pressed the GPS into the mount and mounted it on 2 standoffs. You can now plug in the ESC cable and the O4 cable into the FC. The next step is attaching the front pod to the frame. To do this, we have to take the battery pad and stick it onto the battery plate. You can screw the plate into place. The soft mount is now fixed to the frame. The 2 carbon plates are screwed into horizontal standoffs in the soft mount. They hold the O4 cameras and the GoPro mount. Hidden inside is the receiver and the capacitor. You can screw in the rest of the 3D printed parts, the camera and the GoPro mount. Finally, we can attach the bottom plate with the landing feed. The drone should stand correctly now. The drone is built. If you checked everything, you can now plug it in. I learned that you should always use a smoke stopper. This is a safety precaution between the LiPo and the drone. If I hadn't used it, I would have blown the electronics, because I switched the polarity on the capacitor. When everything fits, it should turn on and the ESC should beep. We can continue to the PC now. I will set up the drone in Betaflight. Due to the amount of information, I will not go into much detail. You plug in the FC and it will connect to the configurator. You can see a lot of tabs on the left. I will now go through some of them. I will quickly explain what the tabs are for. What exactly you need to do, you can find on the Betaflight wiki or on YouTube. So, first we have the setup tab. This is the first tab you see. You can see the setup status of the drone. Then we have the ports tab. Here we configure what input and output we attach to the flight controller. The configuration tab is where you configure the flight controller direction, name and certain modes. The failsafe tab is where we configure what the drone does when it loses signal. The presets tab is pretty much self-explanatory. You have presets from other people for certain drones. The PID tuning tab is where we tune the power, the rates and the behavior of the drone. In the receiver tab, we can set the receiver settings and check if the remote is set up correctly. The modes tab is where we set up the aux switches on the remote, for example, the arm switch or angle mode. In the GPS tab, we can set the GPS parameters, and we can check if it connects to any GPS satellites. One of the most important tabs is the motors tab. Here we set the motor direction and some settings of the motors. The last tab I used for this drone is the OSD tab. The OSD is basically the icons you see in the goggles, for example the battery voltage and the warnings. I want to talk about my learnings. Building a drone is complicated when you have no experience with electrical work and have never researched how a drone works. But with the right tools, I believe that everybody is capable of building one. However, you do have to be very focused and careful. During my build, I made one huge mistake and a couple of smaller ones. However, I was very lucky that I didn't destroy anything. Also, I was lucky to do this at my workplace. I had everything I needed in reach. I want to talk about a few sources that helped me a lot. First of all, I want to talk about fpvframe.ch. If you want a drone or want to build your own drone, fpvframe.ch is the way to go. If you need any advice, you can email them and they will help you with any problems. They have a great online store and a great support system. The next source is a YouTube channel called Joshua Bardwell. It features videos about nearly everything there is in FPV. He explains very good and teaches you everything there is about building, flying and so on. He's very careful about what he picks and he always answers questions. Another source that I use a lot is the Betaflight wiki. This is the direct manual to the Betaflight application I use to set up the drone. They have very thorough explanations on the configurator to help you understand the settings. The last source that I want to talk about are multiple ones. I am talking about the companies that produce the electrical components. Nearly every firm will either give you a manual or have something online to help you understand/connect the components. For example, I use the TBS Lucid manual for every step with the FC and the ESC. They have exact wiring diagrams and good descriptions. Now the drone is done. I hope I taught you enough in this video that you can build your own. And when you're done building, it's time to fly. Now I want to show you my first test flight and some of the clips I took since I built it. Thank you for your time, it's been a pleasure. Goodbye and see you next time.